Welcome back to BAS 121. Just want to run through some of these. So we did the classification. We talked about this in the prior video, classifying your data into training set, validation set, and sometimes maybe yes, maybe not. You have a third set called a test data set. I walked you through the Excel example of how to use Excel Miner to partition your data sets. Normally we would partition them on a random basis. Normal convention, we might put 60 into our training and 40% into our data validation, but you can change those assumptions if you want. You have the selection automatic, or you can change the records. We walked through this in the Excel video. You've got lots of choices on how you want to choose. Lots going to depend on the size of your data and what you're trying to do with it all. We went and showed you this in the Excel, how you partition the data. And we showed you how you could classify new. We used a slightly different rule, but you could use this rule to classify your new data. And based on that, you would come up with their decision. Now, let's talk about, so what we've talked about up to date is a fairly simplistic technique to classify stuff. We went ahead and we looked at our data. We did a bubble chart, and we said, the bubble chart looks like if we could just split this based on one variable credit score, we could say over 640 we approve, under 640 we disapprove. But I think as intuitively you might know, we probably would have a better model if we sort of went in and we said, no, let's consider all the variables. So there's 3 data mining techniques within the classification that you could use. So the first one is what's called the k-nearest neighbor. What the k-nearest neighbor is going to do is, as new data comes in, I'm going to say, I'm going to put the new data up on my matrix, and whatever data points it's closest to, like if John is very similar to Pete, and we approved Pete, then we're going to approve John. So we're going to say, new data, I got John's credit report. I'm going to look a lot like in real estate when you do comparables, whichever house is comparable to the one on the market, that's what I'll price it at. So K nearest neighbor. I'll take the new data and I'll say, which one of my current data points is this most like? And I'll put it there. But there's a little caveat, right? Because do I only include, and that's what the K is for, do I only pick the one it's nearest to? Or do I say the 2 it's nearest to? Or the 3 it's nearest to? So there's some pros or cons to each one of those. Normally, folks, you'd pick between 1 and 5 normally. Obviously, if you just pick one, you might have some very biased data. It might be a very unique situation, and all the other folks around there, we reject it. So, if you think of college entrance, it might be somebody with a very low SAT score, low this, but they might have some exceptional gift. They might be an incredible piano player or an incredible gymnast that the college might want, despite some of the maybe their academics weren't the normal. So K nearest is where you say the new data points, I'm going to put them in, and I'm going to put them nearest the decision we made with the other data points. And you're in K nearest, you're going to normally do the same thing you did with our classifications. You're going to measure distance normally on a simplistic a squared plus b squared equals c squared basis. The second type is what's called discriminant analysis. That's where I'm going to use predetermined classes on a set of linear discriminant functions to predict the variable. So I'm going to say, all right, my predetermined classes might be for credit scores approve or disapprove. And then what I'm going to ask the machine to do is, all right, come up with a linear regression equation for approve and for disapprove based on the variables I give it. This is very similar to when we did multiple regression in the last chapters. So we're going to say discriminant analysis. I know the categories I want. In this case, it might be approved, disapprove. And I'm going to come up with some linear equations to put that score. And based on that score, we'll give it a approved or disapproved. The third type is what's called logistic regression. So logistic regression is a way that I estimate the probability between 0 and 1. And I don't want to get into all of the math, but that's why the word's logistics there, is because you do this with a logistic equation. It's a little misnomer that it's a regression. It's really a classification technique. Logistic regression is a classification technique. But what it does, it puts the probability of that event between 0 and 1, and then I can put a cutoff. I can say, if it's above 50%, I'm going to say approved. If it's below 50%, then I say reject. Now, if I want to be very conservative, I'm going to have the options and the tools to say, no, let's say I'm approving home loans. I might say, no, the probability of they paying back, I might want to be 90% if I want to be very conservative. So the logistic regression has some additional information and power that it gives you over the other two to give you a little bit more flexibility. So just in quick summary of the classification techniques. K nearest, new data comes in. I'm going to look at the new data. Pete's credit history. Pete's is closest to what 1, 2, or 3 other credit files I have on file, and whatever I did with those 3, that's what I'll do with Pete. Discriminant, I say, no, based on the 5 variables or however many variables, we'll come up with an equation, normally a linear equation, that says, here's what I should predict for him or her. And then logistic regression is going to say, logistically, let's take these same 5 or 6 variables, whatever you tell me, and we'll calculate a probability of success. And then based on that probability of success, we will categorize the individual as either approved or not approved. We'll get into these techniques in the next videos. Thanks.